All right, so here we have the problem. If you have an annual starting salary of $50,000 and two options for your raise, which would you pick? An annual raise of $3,000 a year or a 5% raise each year, okay? So after the first year, the annual raise takes you to $53,000. After the first year for the percentage raise, it takes you to $52,500. Second year, we got 56, and then we have over here $55,125. Now, I did not round until the very end, okay? Adding 3, I would have 59,000. Over here, 57,881.25, yes. Over here, I got 60,775.31. Over here, it would be 62,000. That's after the fourth year. Fifth year, 65,000 and 63,814.08. Number 6, 68,000. And I get $67,004.78. Are you getting that too still?
Yes.
Number 7, I got $70,355.02 compared to 71,000. So far the annual raise has been the most. After year 8, 73,872 and 77 cents and 74,000. And after year number 9, we get 77,000 and we get $77,566.41. So right here, after the 9th year, it's better to go with the percentage. If they stay like that for 9 years. How often does it happen that it stays like that? Not, but for this problem, it's staying the same. Okay? So, does it matter how long you plan to stay at the job? Yeah. If you're going to stay there less than 9 years, you definitely want to take the annual $3,000 raise. How long have I been teaching? This is only my second year here, but I taught like 5 years before. I took a big gap. I was a teacher right out of college, had a bad experience, and left.
7 years.
Yeah. All right. Can we write equations to figure out our salary for T number of years? The answer is yes, we can. I forget what's on the next one. Okay, so we'll do it here. Yes, we can. And it is going to look like this. So you might want to write this down. We're also looking at page 119. So if you haven't already, opened up to page 119, and you might want to write this down on that page. So A is equal to, I never know what the variables are, capital P times 1 plus R to the T value, to the T, what is that? Page 119. Whoa. Well, we're answering this question back here. Is can we write an equation to figure out our salary? Okay. this equation and this equation are both essentially the same, okay? The P amount here and what we call Q naught, this is your initial amount. Initial amount. So in the problem we just did, what was our initial amount that we started with? $50,000. It's a Q naught. It's a 0 written slightly below and to the right of the Q. The naught, no. So this is going to be 50,000, and it would be 50,000 over here, times, now, you are either going to do 1 plus a rate. This R is called a growth rate. Or it could be a decay rate. Growth means it is going up and increasing. Decay rate means it is going down. Initial amount. Okay. So 1 is if it was 100%, if it was the exact same over here. But we are looking at a 5% increase. So this was a 5% increase, and writing that 5% as a decimal is 0.05 to the T power. Over here, the A would be your answer after. So it's not 1 plus 0.05, it's just 1.05 to the T power. It's the same thing, only written slightly different. Okay? Now, to the T power, T is our amount of time. Okay? Amount of time for both of these. So let's say we wanted to know what it was going to be after, I don't know, 4 years. Instead of writing out these tables and calculating it that way, we would say 50,000 times, parentheses, 1 plus 0.05 to the 4th power, because we're counting it after 4 years. So on your calculators, 1 plus 0.05, you get 1.05. Raise that to the 4th power. You get 1.21550, something like that. Multiply that times 50,000. And I get, hopefully this works. Don't you love that? $60,775.31. That's after 4 years. Let's check and see if we got that on before. 4 years. 1, 2, 3, 4. There it is. $60,775.31. So we can use this type of formula to help us figure out, bless you, these functions. Is this a linear function? No, it's not linear. It's raised to a power. So we call this an exponential function. Conjunction, junction, exponential function.
You did not just do that.
I did. Schoolhouse Rock, right?
My mom like showed me what that was.
I know.
A good few months ago. I'm like,
Love that stuff. Okay. For some reason, I thought. Okay, let's go to the top of page 119. Let's talk about this one together. Yeah. Top of page 119. Clear ink. Stop. Stop. So the top of page 119, we're going to do number 1 together. Growth versus decay. It says, for each of the situations, set up a table, write a general formula, sketch a graph. We're not doing all that. We're just going to come up with the formula and use the formula. So, A equals, I forget what the values are. Oh, God. Capital P times 1 plus R, could be a minus R, to the T power. Okay?
I remember this.
So A equals, P is your initial amount. So listen to what we're talking about. North Dakota has recently had the fastest growing population out of all 50 states. On January 1st, 2013, the population of North Dakota was 700,000 people. North Dakota's population has been growing by 5% per year. Express Dakota's population N in terms of years since 2013. T, use data from your state if applicable. Okay, so A equals, this is going to be the new population. So this would be the new population. This is what you should be writing in your books, probably, on page 119. P is the initial amount. Initial amount. So what is P going to be for this problem?
Probably the initial amount.
The what?
Initial amount.
Which is how much?
700.
700,000 people. That was as of January of 2013. Okay? It says it has been growing. So I have parenthesis 1. And if it's growing, is that going to be an addition or a subtraction? An addition. I heard that. Of, what does it say? 5%. How do I write 5% as a decimal? 0.05. Now, let's say we wanted to know, and I've already calculated some of this. I only did 4 years, but let's say we want to do it for the 4th year. Okay, to the 4th year. So that is to the power of 4. So 4 is the number or the amount of time. Number of years or amount of time. So on your calculators, 1 plus 0.05, get that total, raise it to the 4th power. Remember, you're going to use the upside down caret or the caret symbol, upside down V. Raise it to the 4th power, you're following order of operations, and then multiply that by 700,000 and tell me what you get.
Yeah.
850,000. Okay, and what? 854. 37. Okay, we can't have 37 hundredths of a person though, so 850,854. Now, okay, so I lied. I actually started with year 2013. So I really only did 4, so I don't have that one down there. It should work. Let's change it to 1, 2, 3. Let's do, instead of 4, let's do to the 3rd year, because I should have the 3rd year. So to the 3rd year, so that's 1.05 raised to the 3rd power. Wow. 810,357? Oh, see, I got 357. Wait. Oh, I see. Yes, I did have 850, 854. I was looking at the wrong column. So I have a column of the population, I have a column for the amount of the increase, and then the total. So if I've been looking at the right column, here it says 850,000, and here after 3 years, 810,337. I had 0.5, but you can't have half a person. Okay? So these are very important formulas to know and recognize. So the new total is equal to the initial amount times 1 plus or minus r and quantity to the t power, where t is the number of years. All right? So after that, here we've got our homework. Let me clear the ink. On Canvas, we're talking about first homework for this last chapter. Just do it. This is topic 7, homework 1, growth versus decay. We actually did kind of the first problem together, and that's part of your homework. So get on Canvas and do that. And there is more, okay? And in addition to that, wanted to give you a heads up. It's a little ways off, but not that far. Your prime final exam. You are going to be given these 6 formulas. Notice that 2 of them are the ones we're talking about right now. So you can expect there's going to be exponents on this final. You probably also recognize this. This is factored form. Standard form. What's this? Y equals mx plus b. What is that?
Is that slope?
Slope-intercept form. So you're going to have linear stuff on there. And what's this? M equals y sub 2 minus y sub 1.
Is that
What is M? Slope. If you're given 2 different points, you should be able to find the slope. So these are the formulas you will expect that we will give you for the final exam. Okay? All right. What questions do you have about today? If you're talking about an increase in a percentage, you're going to take 1 plus the number. If you're talking about a decrease, you're going to take 1 minus that percentage. And make sure you change that percentage to a decimal. Okay? Huh. Yes?
So like, how many percent is defined, like, what grade?
I want to say 15%. It's not a large amount. So if you don't do well, it shouldn't make you fail unless you're really close on the edge. What is that?
The paper from
Oh,
the last quiz.
yes. So that is one that if you've done the homework, we could do a retake on that and make corrections on this too.
Okay.
Okay?
Yep.
And that probably would be helpful for the final also.
Okay.